Here's a complicated one. The integral of x squared times 1 plus tangent x cubed times secant x cubed dx. Let's start like we always do by prepping. So this is the integral of x squared times the quantity 1 plus the tangent of x cubed times the secant of x cubed. Since this is a product, ask, can you expand it? Well, yeah, the x squared can be distributed in here, and the secant x cubed can be distributed in as well. So let's do the distributions instead. We're going to have the integral of, let's see, x squared times secant of x cubed times 1. That's the first distribution. And then we're going to have an x squared times the tangent, or times the secant of x cubed times the tangent of x cubed. That's the double distribution on the right there. So this is our new integrand. Now we can split this up into two integrals. We'll have the integral of x squared secant of x cubed dx, and we'll have the integral of x squared times the secant of x cubed times the tangent of x cubed dx. And we can attack these two problems completely separately. So let's focus on the first integral. Notice that it's a product, so it would suggest a substitution now, since we FOILed it out. The only thing in parentheses is x cubed, so we'll do that. Du dx will be 3x squared, so divide by a 3 and multiply by a dx, the usual rigmarole, and we get 1/3 du is x squared dx. Does it fit? Yep. Right there and right there, the bookends. So we can replace these two terms by 1/3 du. We can replace this by a u, so we have the integral of secant of u times 1/3 du. The 1/3 is a constant, comes along for the ride. The integral of secant is the natural logarithm of the secant plus the tangent functions. And so this becomes our antiderivative in u, and if we back substitute, we have 1/3 the natural logarithm of the absolute value of the secant of x cubed plus the tangent of x cubed. So there's the antiderivative on the left. Now let's focus on the right. Notice that this is a product who suggests the same substitution. And that substitution fits here and here. So let's just move the substitution work over so we can see what's going on. We'll replace the x squared dx with the same differential of 1/3 du, like last time. The two x cubes can be replaced by u's, and so we have a secant of u times a tangent of u times the 1/3 du, and that's what we're integrating. 1/3 comes along for the ride, and the antiderivative of secant tangent is just secant. So if we back substitute, we're going to have 1/3 secant of x cubed as an antiderivative for the second integral. If we add our two results together and add an integration constant, we now have the general antiderivative for the problem.